Alright, hello, welcome to part 2 of Undetermined Coefficients, episode 3b of chapter 5. So, what can we do here? What do I mean? What's this second part? So, suppose we have this equation, qy is equal to g, and then g is equal to some plus, or f times g plus h, or something like that, right? It's this group of function. It's this combination of other elementary functions, right? What can we do here? So a first example I'm going to look at is, well, what if we have e to the t times t plus 1 or something, or t, or c, a t plus b, right? Something like this. So what if g is equal to this? So first thing we're going to do, well, okay, we want to find a particular solution. So yp is equal to, we're going to make our guess, e omega t, a t plus b, right? But this has 3 unknowns, right? And so we're not going to have enough equations if you actually try to work it out and solve this. However, we can simplify this by popping the exponential term out, and we end up with CAT plus CB, which essentially, since these are constants, you can kind of absorb them. So we basically have our guess. So our particular solution is basically going to be this, just AT times AT plus B. We basically just pop that exponential out. And so the same idea goes if we guess, if we happen to have g is equal to e omega t plus times some cosine, right? So in this case, the particular solution is, okay, we could do, okay, c omega t and a cosine cosine alpha t, right, plus, so suppose this is alpha, right, plus b sine beta t, right? And so we basically have the same problem, and then essentially all we really want to do is just, okay, e omega t, a cosine alpha t plus b sine alpha t, and then this is actually an alpha, not beta, right? So that's what we get. And essentially when we have the products, we basically just pop exponent, pop the exponential term, and we basically find the yp of this, of the other function. So we find that particular solution and then just tack a exponential term on top of that, right? So pretty easy, pretty simple. What about adding? Right, so what if we had e t plus t, right, plus a t plus b, right? What if we had that? Well, each of these is going to be, what we can do is we can basically just look at each of these individually. So we have one particular solution, two particular solutions, and then all we are saying is a particular solution is going to be one, the first particular is going to be the sum of these two. So in this case, what does that look like? Well, that's just going to be yp is equal to a plus bt plus c. And I actually forgot to talk about what happens if g is a constant number. But if g is a constant number, if g is a constant number, we can basically just, that particular solution is just going to be a constant, right? Because it's you can think of it as a polynomial. So that's what we get. So, for example, let's think about, okay, what is the particular solution to g is equal to e omega t times cosine alpha of t plus, and so this is going to have some constant. I'm just going to call it c1, c2 plus c3 t squared. Right, so what is this particular solution going to look like? Well, write this out. Okay, a e omega t, or no, oops, I made a mistake. A omega t times a cosine omega t plus b sine omega t plus a t squared plus p t plus c. And then obviously y is going to be our fundamental solutions plus plus the particular solution, right? And so that's pretty much it for method of undetermined coefficients. Pretty straightforward. Not too much. This obviously only works with specific classes of functions. The next method I'm going to look into works with any sort of functions, but it's a little more complicated, has a few more steps to it. Good luck.